Hello everyone, welcome back to our channel. This is series 13 Ecotech Fusion Intelligent Ideas Next Generation. Come, let's go into the video. The first idea for today is challenges and opportunities for implementing AI green HR in Bangalore's manufacturing sector. So here the Bangalore is known as India's tech hub, which is increasingly becoming a focal point for smart manufacturing. Integrating AI with green human resource management, that is HRM, in this sector presents both significant opportunities and notable challenges. AI can transform traditional HR practices such as recruitment, performance management, and employee engagement into sustainable, eco-conscious process. However, adoption is often hindered by the factors like high implementation cost, lack of digital literacy, and resistance to change in traditional industries. So what is the innovation aspect? AI-driven skill mapping. So identifying and training employees for green roles using AI-based skill analytics. Predictive HR analytics for resource optimization. So here leveraging AI to predict workforce needs and optimize energy and the resource consumption per shift or project. Smart wearable and IoT integration in workforce monitoring. So using AI with IoT to monitor and minimize the environmental impact during the operations such as energy efficient machine used by employees. Eco AI chatbots for training and AI green awareness. So here implementing intelligent bots that guide workers on sustainability practices on shop floors. Paperless HR system and biometric access. Using AI for documentation, compliance and access system to reduce the carbon footprint. What is the future scope? Green HR policy modeling using AI. So simulation and evaluation of new HR policies for environmental impact before the implementation. AI green HR integration with ESG reporting. So here it enhances the environmental, social and governance compliance and the transparencies. Collaborative AI platform for industry-wide green practices. So it builds the shared AI platforms across the Bengaluru manufacturing ecosystem to develop green HR standards. Smart AI-driven audits and compliance checks. It uses AI to conduct internal audits for sustainability and regularity compliance in HR functions. Upskilling for AI green HR roles. So it develops future-ready HR professionals, training in both AI tools and green practices. The next idea for today is integration of carbon-based nanomaterials with TiO2 for enhanced electrode conductivity in glucose sensing. The TiO2, that is titanium dioxide, is widely recognized for its chemical stability, biocompatibility, and photocatalytic properties. However, it is relatively low electrical conductivity and can limit its performance in electrochemical glucose sensing. So, to overcome this particular challenge, carbon-based nanomaterials like graphene, carbon nanotubes and reduced graphene oxide can be integrated with titanium dioxide to create a hybrid nanocomposite electrode with improved electrical properties. So this innovative approach leverages the high surface area and excellent conductivity of carbon nanomaterials to facilitate faster electron transfer, leading to higher sensitivity, lower detection limits, and better response system in glucose sensing. What is the innovation highlights? Hybrid nanocomposite formation. So the synergetic interaction between the titanium dioxide and carbon nanomaterial enhances the charge transport and electrode stability. Enhanced electrocatalytic activity. So carbon materials provide conductive pathways while TiO2 offers active sites for glucose oxidation. Surface functionalization. So here the functional groups on graphene, CNTs can be modified to improve the enzyme's immobilization, or it can facilitate to the enzyme-free detection. Flexible sensor platform. Printable nanocomposite ink for screen printing sensors on flexible substrates, say for example PET or paper. Low power and miniaturized devices. So integration with microcontrollers and portable electrochemical system for real-time on-site glucose analysis. Future scope. There are some extensions that can be done, that is smart food monitoring system. Deploying in food packaging to monitor the sugar content in real time for quality assurance and health conscious consumers. Non-enzymatic biosensor development. So replaces traditional enzymes with metal-doped carbon titanium dioxide system for more robust and long-lasting sensors. Integration with IoT and AI. Developing IoT-enabled sensor arrays with AI-based data analytics for predictive quality control in food industries. Multi-analyte detection platform. Extend the same nanocomposite platform to detect other food biomarkers like lactate, cholesterol, or urea. Sustainable fabrication approaches. So it uses green synthesis techniques. For example, a plant-based reduction of graphene oxide, which is eco-friendly sensor development. The third idea for today is Doppler shift extraction in passive radar using digital TV signals for low altitude UAV tracking. The passive radar system utilizes existing electromagnetic signals like digital TV broadcast to detect and track the objects without transmitting their own signals. So this makes them very cost effective, covert and ideal for urban and civilian application. Here, Doppler shift extraction is a critical or crucial technique used to identify the velocity and direction of the moving targets, especially low altitude unmanned aerial vehicles like drones. This topic actually focuses on how DVB-T, that is digital video broadcasting terrestrial signals, can be used as illuminators of opportunity, and how the resulting Doppler frequency shift caused by the drone motion can be extracted and analyzed to track their position and speed. The approach provides a non-invasive, stealthy alternative to conventional radar system, particularly for monitoring no-fly zones, critical infrastructure, or urban airspace. So moving on to the innovation part, exploiting public signals. So it utilizes the existing TV broadcast signals, avoiding the need for dedicated radar transmitters. Advanced Doppler processing. The development of algorithms to detect small Doppler shifts caused by slow, low-altitude UAVs flying at different speeds and angles. Clutter rejection in urban areas. Innovative filtering methods to differentiate between UAV and background clutter from building, birds, or cars. Multi-baseline system. It uses use of multiple receivers to triangulate and enhance the precision of UAV localization. Software defined radio, that is SDR platform. Implementation of SDRs for flexible and reconfigurable drone detection solution. What would be the future scope? AI enhanced Doppler analysis. So integration with machine learning for automatic pattern recognition and classification of UAV signatures. Portable passive radar units means the development of compact mobile systems for temporary deployment at public events or sensitive locations. Networked surveillance system. Creating networks of passive radar nodes that share Doppler data for real-time 3D UAV tracking. Integration with other passive devices. So it combines with acoustic, thermal or RF fingerprinting sensor for improved accuracy and reduce false positive. Defense and Homeland Security application. So deployment around the borders, airports and military bases for early detection of unauthorized drone activity without RF emission. Moving on to the final idea for today, fatigue resistance improvement in bituminous pavement via induction healed metallic reinforcement. Here, the bituminous pavements are widely used in road construction but are prone to fatigue cracking due to repeated traffic loads and temperature variation. The traditional repair techniques are often reactive and resource intensive. This study here, it explores a novel approach to enhance the fatigue resistance by embedding metallic reinforcement, that is steel fibers or scraps, into an asphalt mixture, enabling induction heating based self-healing. When it is exposed to the controlled electromagnetic induction, the embedded steel heats up and transfers the thermal energy to the surrounding bitumen, softening it and allowing the micro cracks to heat automatically. So this process significantly extends the service life of the pavement and reduces the need for frequent maintenance. What would be the innovation aspect? Self-healing mechanism using steel-based inductive fillers. Here, the steel crabs or fiber serves dual purposes, that is reinforcement and heating element under induction. Smart fatigue control. It enables targeted on-demand healing of fatigue cracks without full resurfacing or lane closure. Increase flexibility and load carrying capacity. So it improves the resistance to the crack propagation under cyclic loading. Energy efficient management or maintenance. It requires minimal surface intervention and can be automated for scheduled or condition based repairs. Use of recycled material. So it promotes unsustainable infrastructure by utilizing the industrial steel waste or recycled steel fibers. Moving on to the future scope, integration with predictive maintenance system means it combines with the embedded sensor and AI to detect early stage cracks and trigger induction based healing. Standardization and policy adoption. It develops specifications for incorporating metallic reinforcement in bituminous mixers for national highways. Induction vehicle deployment. It uses the use of specialized induction trucks to remotely active healing process on active roads during off-peak hours. Advanced mix design optimization. So the study various shapes, size and concentration of steel inclusion for optimal fatigue resistance. Multi-cycle healing capability. So it evaluates the long-term performance of the pavement under repeated induction healing cycle. Hope you are interested to know about very good ideas like this for your project, research and any exhibition kind. Please be stay tuned for more information. Thank you.